You just did it. A few seconds ago, to land on this video, you typed something, or tapped something, and a page appeared. It felt instant, effortless, like flipping a light switch. But what if I told you that in the time it takes you to blink, your request just traveled thousands of kilometers, passed through a dozen different machines, asked a global directory for directions, performed a secret handshake with a complete stranger, and agreed on a password that no one watching could ever steal, and then came all the way back? All of that before you blinked. We're going to slow those milliseconds down to minutes, and by the end, I promise you, you will never look at your address bar the same way again, because the most surprising part isn't how it works, it's that it works at all. Let's start with a problem. You want a page that lives on a computer called a server. That server could be in another city, another country, another continent. And here's the uncomfortable truth. Your computer has absolutely no idea where it is. You typed youtube.com, but that's a name. Computers don't navigate by names. It's like telling a taxi driver, "Take me to Sarah's house," with no address, no city, nothing. Useless. So before anything else can happen, your computer has to solve three problems in order. 1. Find it. 2. Connect to it securely so no one can listen in. And 3. Ask it for the page and turn whatever comes back into something you can actually see. Find it, connect to it, ask it. Everything that happens next, all of it, is just those three problems being solved faster than you can perceive. Let's take them one at a time. The first thing your browser does is something surprisingly human. It checks its own memory. Have I been here recently? Do I already know the way? If it's your first visit, that drawer is empty. So now your computer has to ask for directions, and the system it asks is one of the most important and most invisible pieces of the entire internet. It's called DNS, the Domain Name System. Think of DNS as the phone book of the internet. You give it a name, youtube.com, and it gives you back a number, an address like 142.250.190.78. That number is called an IP address, and that's what computers actually use to find each other. But here's where it gets interesting. There is no single giant phone book. No one computer could possibly hold every website on Earth and answer billions of requests a second. So instead, the question gets passed up a chain. Your computer asks a helper called a resolver. The resolver asks, "Who handles .com addresses?" Then it asks that server, "Okay, who specifically handles youtube.com?" and finally gets the real answer. It sounds slow. Multiple computers, multiple hops, possibly across the world, and yet this whole journey usually finishes in a few thousandths of a second. How? Because almost everyone along the way remembers the answer for next time. Your computer caches it. Your internet provider caches it. The result is a phone book with no center that somehow always knows the answer. Now your computer finally knows where to send its request. Problem 1 solved. But knowing the address is not the same as knocking on the door. To actually talk to that server, your computer can't just shout data into the void and hope it arrives. The internet loses things. Packets get dropped, arrive out of order, vanish entirely. So first, the two machines agree to talk. Your computer says, "Hey, can we talk?" The server replies, "Yes, I'm here, go ahead." And your computer says, "Great, here we go." 3 messages. That's called the TCP handshake, and it builds a reliable channel, one where nothing gets lost and everything arrives in the right order. But there's a terrifying problem with this pipe. It's completely open. Every router your data passes through, every network in between, they can all see what's flowing through. If you typed a password right now, it would travel as plain, readable text past strangers you'll never know about. So how on earth is anything you do online actually private? This is where something genuinely beautiful happens. Your browser and the server perform a second handshake, the TLS handshake, and in it they agree on a secret key to scramble everything, a password to lock the data. But think about what that requires. They have to agree on a secret password while shouting at each other across a public channel where everyone is listening. It's like you and a stranger needing to agree on a secret code in a crowded room with everyone listening to every word, and somehow ending up with a shared secret that no one else in the room can figure out. And they pull it off. Using some genuinely elegant mathematics, the two sides combine information in a way where an outsider who heard every single word still can't reconstruct the key. From this instant, everything is scrambled. Those shadowy listeners now see nothing but noise. And there's one more check. Your browser also demands the server prove its identity. It presents a certificate, like a passport, signed by an authority your browser already trusts. So you're not just talking secretly, you're sure you're talking to the real site and not an impostor wearing its name. Problem 2 solved. You've found the server, you've opened a secure, private line, and you've confirmed it's really who it claims to be. Now, finally, you can ask your question. This is the part most people think of as the internet, and it's almost anticlimactic after everything we just went through. Your browser sends a short, politely formatted message called an HTTP request. Stripped down, it basically says, "Get me the page at this address, please." The server catches it, and now the server goes to work. It figures out what you asked for. Maybe it runs some code. Maybe it reaches into a database, a giant organized store of information to pull up your recommendations, your subscriptions, your watch history. Then it builds a response and sends it back. A status code, the famous 200 OK, meaning success, here you go, followed by the page itself, written in HTML. But here's what most people don't realize. What the server just sent you is not a page. It's a blueprint. HTML is just text, a description of what the page should contain. A heading here, a video player there, a list of links over here. There are no colors yet, no layout, no motion. It's the skeleton with no skin. So who turns this skeleton into the polished page you actually see? You'd be forgiven for thinking the server builds the page. It doesn't. Your browser does. And this final act is wildly underrated. Your browser reads the blueprint and immediately realizes it's missing pieces. I need a style sheet to know the colors and layout. Another request flies out. I need the JavaScript that makes buttons work. Another request. I need this image, this font, this thumbnail. More requests, sometimes dozens, all racing back at once. And as each piece arrives, the browser assembles it. It calculates exactly where every element goes. This is called layout. It applies every color and style. It runs the code. And then, pixel by pixel, it paints the finished page onto your screen. What felt like one instant action was actually a frantic, beautifully coordinated assembly happening right inside your device, a builder receiving a blueprint and a pile of parts and constructing a skyscraper in a few hundred milliseconds. So that's the journey, except I left out the strangest part, and once you see it, the whole internet looks different. That server you connected to, the one that gave you the page, it's probably not the real one, and that's completely on purpose. For any large website, the IP address DNS handed you didn't point to one machine in one place, it pointed to the nearest copy, a server that might be sitting in your own city, inside a network called a CDN, a content delivery network. Big sites keep clones of themselves all over the planet, precisely so your data never has to travel far. Here's the part that breaks people's brains. The IP address you got for this exact site might be completely different from the one your neighbor gets for the same name. You're being quietly routed to whichever copy is fastest for you, and they're routed to theirs. One website is an illusion. It's thousands of machines scattered worldwide wearing the same name. And this changes everything about how you should picture the web. It isn't a place you go to. It's a place that quietly comes to you, that prepositions itself as close to you as it can, and then spends a staggering amount of engineering effort hiding the distance so the whole thing feels like a light switch. Step back and look at what just happened. To show you a single page, a global directory was consulted, a reliable connection was negotiated, a secret was agreed upon in front of eavesdroppers who couldn't break it, an identity was verified against a chain of trust, a server reached into a database, sent back a blueprint, and your own device assembled it from parts gathered across the network, and the page itself may have been served from a machine quietly waiting a few kilometers from your chair. Billions of times a second for nearly anyone alive, mostly without failing. No single person designed all of this. It was built in layers over decades by thousands of people who mostly never met, each solving one of those three problems a little better than the last. Find it, connect to it, ask it. So here's what to remember. The next time you type an address and hit enter, picture the real journey. Your browser checks its memory, DNS finds the address, a TCP handshake opens a reliable line, a TLS handshake locks it with a secret agreed upon in front of eavesdroppers who couldn't break it, an HTTP request asks for the page, the server reaches into its data and sends back a blueprint, and your browser, the unsung hero, builds the finished page from a flurry of parts, very likely served from a copy waiting just around the corner. 6 steps, a trip that may cross oceans, a secret negotiated in front of strangers, all in less time than it took me to say this sentence. We treat the internet like magic, like a light switch. But it isn't magic. It's something stranger and far more impressive, a planet-sized machine built by people who never met, performing this miracle for you right now and making it look like nothing at all. So the real question isn't what happens when you type a URL, it's how did we ever make something this complicated feel this simple? If the strangest part to you was that secret in plain sight handshake, how can two strangers agree on a password while everyone's listening? Good, because that's the entire next video.